Our goal is to classify the shape shown and then to find an equation that would reproduce it. So we're going to use Desmos to do that, and although I have this in Desmos, you might only have it on paper, so I'm going to use it as if it were on paper. So we're looking at this thing in orange, which is some sort of polar graph, and we identify it as a rose, and in fact as a 3-petal rose because of 1, 2, 3 petals, which means it's going to be something which is a sine of 3 theta or a cosine of 3 theta, the 3 coming for the number of petals. Remember that odd number of petals gives us odd n, but even number of petals gives us an, n over 2. So if it had been a 4-petal rose, that would be a cosine or sine of 2 theta. But since it's odd, it's very simple. It's sine or cosine of 3 theta, and what we're going to do is just see how that looks and go on from there. So we'll go and start a new Desmos page. Alright, nice new blank Desmos page. The very first thing we'll probably want to do is get into polar graph mode, which we do by going over to settings here, and then choosing polar graph. And then we can close it. And that is basically the same standard 10 by 10 grid that we're used to, but it's done in polars. You can see there's marked in radians. We could have made it degrees, but our image here is in radians, so we might as well leave it. It also doesn't really matter for what we're doing here. And then we say that the 3-petal rose has a form which is some number times sine of 3 theta. And tells us, well, that's no good until you add a thing for what a is equal to, so we'll do that. And we see that that's a equals 1. Before we go much further, we should check and see, oh wait, our petals, our rose seems to have sort of a sideways shape, whereas this looks more like a Y, so that's probably indicating that this should really be cosine. The phase of the angle gives us different rotations, most importantly sine and cosine, which end up being 90 degrees rotated relative to each other. And what we have here looks, at least in miniature, like what we have out here, but the scale of it is wrong. So now we want to go back to our actual graph, and we want to say, well, that graph seems to have value all the way down to 0, but it also says that when theta equals 0, our function r should have a value of 8. And if we go back here and we say when theta equals 0, cosine of 3 times 0 is cosine of 0, which is 1, so we have a magnitude of a, so we would like a to be 8. And we see that pretty quickly that is basically the same. There's some artifacts about how I pasted this in, so that's why it looks a little blurrier, but basically the same curve. So we can see that that works out fine. As another example, we would have this graph if we would be asked to both classify and then find an equation for. So we look through our loose zoology of polar curves, and we see that this is something called the cardioid, named so because it looks like a heart, kind of. Not really, but enough for mathematicians. And so we're going to want to use the formula for cardioid, which is some number plus or minus that same number times sine or cosine of theta. We're only going to deal with single powers, or single multiples of theta here, so we're not going to have like sine 2 theta or cosine 3 theta or something like that for the cardioid, although that's a perfectly acceptable kind of graph. It's not one you're going to be asked to identify offhand. So we do the same sort of thing as we did before. We're going to open up a new tab and we're going to open up a Desmos window. And we're going to type in the formula for a cardioid, which is r equals a, and I'm going to put plus sine theta. I don't really know which, so I'll just put one of them. Again, Desmos says, wait, I don't know what a means. Before we even do that, I should have actually a plus a sine theta, so we'll do that. And we'll take, okay, Desmos, take variable a, and it just gives the value of 1. And we see a couple of things. 1, it's not the right scale, but 2, it's also oriented the wrong way. So that kind of implies to us always that we should just try the cosine. And we say, oh wait, that looks like it fit properly. That's the right orientation. I guess to make it easier, we should also go to polar graph, come back, and we see that basically it is too small. And so we're going to have to rescale it. The way we're going to rescale it is to find a point, any point at all, that's convenient to read. I'm going to pick that when theta equals 0, which is this line, I see that r equals 6, which is this value. So in my formula, I would also expect that when theta equals 0, r equals 6. Again, we pick any convenient point. If it had been sines, we probably would have picked pi over 2 rather than 0 most of the time, but whatever works that's easy for you, that's what you pick. It should pass through all the points, therefore you can have it pass through any one of them. So we go back here and we say, well, when theta equals 0, then cosine of theta is 1, so r equals a plus a times 1, which is r equals a plus a, which is r equals 2a, and since we want when theta equals 0 that r equals 6, then a has to equal 3. And if we pop back and forth, we can see that it basically seems like it's the correct scale. It's going through all the points we had before. So it's really as simple as that. The key thing knowing that we can identify the type zoologically and that we know what the formula is and play with it. And that's about it.